Alright, so recently I encountered a question which was that you have to figure out Pythagorean triplets which add up to 1000, and you have to figure out all of them, and you had to like figure out the maximum of them or something. I don't even remember all of that, what the question really was, but the main part of it was figuring out the Pythagorean triplets which add up to 1000. So that can be rephrased as this question: right angle triangles with a given parameter, right? So for example, if you have 1000 as our perimeter, then you just want all the right angle triangles which like have the perimeter 1000. That could be categorized as one of these two things. One, that you could have a primitive right angle triangle, so all the PRTs of 1000, and you could have scaled up primitive right angle triangles, so that would be the PRTs of thousands divisors, that times the other part. So like you could break 1000 as 2 times 500, so you just have all the primitive right angle triangles which have perimeter 500. So PRT function takes the perimeter, gives like ABC as its output, but this is a vector, of course. So you would have all of this, that times 2. So a set containing this thing, it's not just giving out ABC, it's actually giving the set of all these ABCs, but makes sense, right? Yeah, there's not like a formal definition for PRT that I'm putting up, but you kind of get what I'm doing, right? So 2 times of PRT 500, and then you could also have things like 5 times PRT of 200, and so on. So basically all divisors of 1000, so like PRT of some certain divisor of 1000, and then 1000 upon that divisor over here, scale up the triangle, and there you go. So yeah, just keep on going like that. Eventually you're gonna get like PRT 1, which I mean there's no right angle triangle with some 1, but yeah, stuff like that, and then 1000 times that. Okay, so that's the set containing all the right angle triangles which have some 1000. Now the question really is, how do you get primitive right angle triangles with a certain perimeter? And for that, I'm making this video. um, so first you need to know kind of a parametric form of primitive right angle triangles. So basically it's a way to generate PRTs, primitive right angle triangles, of course, it's an abbreviation for that. So it's a way to generate PRTs given two numbers x and y. So it's basically this thing, and just look at this diagram once and then you understand what's going on. So A and B are not in certain order, although it looks like A is less than B. A and B are not having any order. So that's why without loss of generality you can assume that A is odd and B is even, or the vice versa stuff and stuff like that, right? That's why I have not kept an order. Okay, because eventually you will have to assume something like that in this proof. I'm not gonna go through the whole proof. You can read it. I'll put this note as a PDF in the description. But yeah. Okay, so final result is that C equal to x squared plus y squared, B equal to x squared minus y squared, and A equal to 2xy, where x and y are two co-prime numbers, and we have the restriction that x is bigger than y. I mean, of course, because B has 2x squared minus y squared. Okay, and then putting this parametric form into our main equation, a plus b plus c equal to p, you get this equations: x times of x plus y equal to p upon 2, which is another natural number n. And from that you can get two inequalities which you put together to get this range for x. So x has to be bigger than square root of n upon 2, less than square root of n, where n is p upon 2. And from all of this you can also get this result, that n can't be a power of prime, because then you would have this inequality from the first part of this inequality, which is not true for any prime p, in fact. And k is like 1 2 3 4, so k is a natural number, it's not 0. So yeah, this is not going to happen. Okay, so let's go for an example. Let's figure out all the PRTs of something like let's see, 40. Yeah, so if our perimeter is 40, can you figure out a primitive right angle triangle with that perimeter? So the first step is of course get n, which is p upon 2, so that's 20. Write down our equation x times of x plus y, which I'm going to rename as z, equal to 20, right? And then get the values of x from this range. So our range is square root of 10 to square root of 20, so x has to be less than that and stuff like that. Okay, so this thing is 3 point something less than x less than this thing is 4 point something, so x has to be 4, right? So like this simple example, you can see how powerful this range actually is. We didn't have to do anything and we just got the value. Easy. So let's also like do another example. So let's disprove, okay, let's actually prove that let's prove that 1000 doesn't have a PRT. So there's no primitive right angle triangle which has perimeter 1000. That's what we're going to prove. So 1000 can be written as 2 power 3 times 5 power 3. Square root of n upon 2 would be square root of 500, of course, and square root of n is square root of 1000. Oh wait, okay, no, sorry, p is this thing. N would actually be 2 square times 5 cube, which is 500. So now n upon 2 would be 250. Yeah, better. And this would be 500. Okay, so x is in this range. Okay. Oof, this is the inequality. So like we can say x is bigger than or equal to 16, because sort of 256 is the very next integer, and I guess square root of 23, so like 23 square is 400 plus 120 plus 9, right? Yeah, it's like 529, so it's less than 23. Okay, what about 22 square? That's going to be 4 times 121, which is 484. So yeah, I guess this works. So it's less than or equal to 22. So in that range you won't be looking for x. So as I said, x and y have to be co-prime, so and like that means x and z are also co-prime, right? So x times z equal to n, which is 2 square times 5 cube. These are co-prime, so what you actually have to do is, and of course x is less than z because z is x plus y. So what you will have to do is you will have to distribute these clusters, which are basically powers of primes. I don't have a good word for this. I'm gonna say it's clusters, because you won't be able to split this as 2 times 2 and then give 1 2 to x and 1 2 to z. You can't do that, so you have to keep them together. That's why I'm calling that a cluster. Basically you have to distribute these powers of prime into x and z, right, so that they are not having any prime in common, and those are co-prime till the end. And yeah, distributing that, you have to figure out an x which is in this range. So let's try doing it. What's the smallest x that you could have? 1, of course, which is not in the range. Next you have 2 square, that cluster, which is 4, not in the range. And next you have 5 cube, which is 125, not in the range. Next cluster would be 2 squared, so cluster or product of clusters or whatever would be 2 square times 5 cube, which is 1000 itself, not in the range, of course. So yeah, there you go. There's no x in this certain, okay, in this particular range, which means you won't get a z. Like, yeah, in this particular case z would be 1000. Over here z would be 125. Over here would be 4, and this is like wrong because z is x plus y. How could it be less than that? So from here you don't even want to look forward, because you're just not going to get anything nice. So these are the only values that you could get for x and z, but guess what, those are not in the range. In fact, nothing is in the range. So yeah, you just disproved you proved that you just proved that 1000 does not have any primitive right angle triangle with its perimeter 1000. That's what I should say. Yeah, and you could go like that. You could take all the divisors of 1000 and like just case wise keep finding all these PRTs with those perimeters, and yeah, that's gonna give you the list of all PRTs. And turns out that all right angle triangles that have perimeter 1000, well, there's only one right angle triangle actually, which is this thing 20. So like it has this a equal to 25 times 8, b equal to 25 times 15, and C equal to 25 times 17. So yeah, this is the very case where we actually like did the 40 thing. So you know, parameter 40, we did that. What did we get? We got x equal to 4, right? Yeah, and we also got y equal to 5, sorry, z equal to 5 in that case, because 20 equal to 4 times 5. So for parameter 40, this is what you would get. And in fact, like, you go further than that, it's gonna give like y equal to 1, and then from here you calculate a, b, c, you get these values. So a equal to 2xy, that's equal to 8. B equal to x minus y square, that's 16 minus 1 is 15. C is 16 plus 1, which is 17. So you get this triangle, you just scale up this triangle by 25. And that's how you get, the right angle triangle with perimeter 1000. There's only one such right angle triangle. So yeah, this is useful. Okay, that's it. I'll see you guys next video.